Mr. Morihiko SUGINO, the CEO of Fuji Design. He graduated from Keio University and joined Applied Chemistry Department of Kobe Steel in 1970 and established Fuji Design in 2011 after resignation from Kobe Steel. And he will present today a recycled carbon fiber meeting SDG targets with a low LCA value. He's also is online. Hello.
Hello, SUGINO speaking.
Oh, so since everything is ready here, if you're ready,
Yes.
you can go ahead. 여러분
Yes.
박수로
Okay.
모시겠습니다.
Yep. Okay, thank you very much to introduce me. I'm SUGINO, CEO Fuji Design, and today I'm very much glad to introduce new recycling process of carbon fiber from CFRP edge materials or prepreg. Okay, next please. Yes. We can pass SDGs examination in Osaka City Government Bureau and attended the SDGs exhibition held on 16 to 17 October this year. We displayed our our recycled carbon fiber products such as compound pellet and molded purse and also non-woven felt. New pyrolysis recycled carbon fiber, we call it RCF, is getting into mass production in March this year in Japan for automobile, sports good and also industrial use. Next, please. During development, sustainability is our goal. It means from recycling process to final application in the market stage should be connected together in the market. So this is our policy during our development. Okay, next, please. RCF reinforced products should be easily compounded or prepared the composite. The requirement of sustainable establishment of RCF are first, securing stable traceable supply source of RCF. And next, RCF property should be equivalent to original CF. This is virgin CF to be easily accepted in the market. Because market always looking for the more strong, more stiffness to use. So we must recycle the material at the same level of virgin material. And the third one is obtained low CO2 consumption. It means LCA. For recycling process should be accepted in the compound or composite product design. So right now, LCA is most important issue in carbon fiber area. And many steel making company is called the negative campaign of CF carbon fiber of this higher LCA value. But we can solve this problem right now. Next, please. I'd like to show outline of new technology. Left hand photo shows pyrolysis and carbonizing equipment. And front door, if we open the front door, we can see the reacting chamber. And the size is 2.5 meter width, 2 meter height, and 3 meter depth. And the pyrolytic temperature is controlled below 480 degrees C. This is very important point to protect carbon fiber surface oxidation. Partial oxygen pressure of pyrolysis gas is controlled below 80%. Less than 80% partial oxygen pressure is required to obtain non-oxidized RCF. CFRP or CF prepreg in the furnace is heated from 300 degrees C to 480 degrees C to carbonize and residual amorphous carbon content. It means residual amorphous carbon means came from matrix resin of thermoset resin, for example, epoxy. And this residual amorphous carbon content is controlled from 3 to 5 weight% to work as sizing materials for carbon fiber. This sizing effect we found is very new issue because we have no need to put the sizing materials onto the recycled carbon fiber. The pyrolysis process is developed to control high temperature burnout gas from LPG burner. And combustion gas is induced into pyrolytic treatment zone. It means evolved gas from reacting chamber will return to the burning area, heating the area with a small amount of oxygen from air. And as a result, we can save the LPG gas consumption. It means we can reduce the consumption of the energy, means achieve the LCA value lower. So it is obtained good LCA value of 2.5 CO2 ton per ton, and evolved value is similar level of steel making. Official value is 2.3 CO2 ton per ton. It's very close value compared with the virgin materials LCA value. Virgin materials have almost 10 times of recycled carbon fiber or steel. After pyrolysis of CFRP or prepreg, we can get RCF to keep same property of original virgin carbon fiber, and it will be chopped 10 to 25 millimeter length for size for good feeding property to twin screw extruder. Left hand Right hand is twin screw extruder in Japan. And another application is around 100 millimeter length of RCF fiber to make non-woven fabric. So right hand photo shows a twin screw extruder to compound different type of plastic. Later, I'd like to show you the plastic name, but and also we can obtain high filling of carbon fiber up to 50% because of the some structure of amorphous carbon get the good result. Okay, next please. Okay, I'd like to explain the process of how to achieve SDGs. We recognize 3 key items are required to achieve SDGs. First one, stable supply of CFRP edge material or prepreg from different production area. So we must get the multi-source to obtain the stable supply of the material. Next is to accept in the market, to be accepted in the market. RCF must enough mechanical property correspond to virgin carbon fiber. It's also very important. If RCF performance is lower than virgin materials, it is very hard to accept in the market. Third one is low cost RCF preparation process, which is strongly related to the energy consumption, and also as a result, low LCA value is achieved. So once more to simplify, next please. Next is almost same figure, but I'd like to simplify And the main material source for recycle is as following industry: aircraft manufacturing, and hydrogen cylinder, and CNG cylinder in automobile. Hydrogen cylinder material is high grade, and the CNG is normal grade. And also we can get sports and industrial good for this purpose. From these sources, we can get prepreg or cured aged CFRP or used parts. In case of hydrogen cylinder and CNG cylinder, we can get already used parts out of life parts. In recycling pyrolysis, we select several thermal heating program according to the material condition and thickness. If the thickness is thicker, we can elongate some temperature area to elongate the treatment time to get the same RCF property for compounding or non-woven fabric preparation. For compounding RCF, residual carbon content is controlled 3 to 5% for non-woven fabric. residual carbon content is controlled lower than this value. And we already started to marketing of compound pellet to automobile and sports and the industrial market. Next, please. This is actual picture, a photograph, and from extraction of the hydrogen cylinder or aircraft edge material, and the different material is aircraft preplates. And the next figure shows the pyrolysis. Oh, sorry, just wait. Next photograph shows the outside looking of the pyrolysis and the carbonized furnace. And the backside, it is the very secret area, and we can recycle the gas from heating, and also evolved gas is returned to the furnace with small amount of air. And the obtained material is next very shiny surface you can see. This shiny surface means we can get a very good condition of the carbon fiber. No oxidation. If residual material is on the surface, it is very dark and not shiny surface, but we can get every time very shiny surface. And also, please see, normal recycling method require some chopped material, partly destroyed by some block, but we can obtain the material like this long fiber material. And this long fiber material is put into the cutting machine. It is guillotine cutter, and wide materials or very small materials, and obtain the chopped fiber like this. And this chopped fiber is directly put in the twin screw extruder. And we have a lot of technology of the compounding recipe. In the past, I have a consultant of many resin company compounding technology. So I already have many kind of resin, such as PA, PC, and LCP, PPS, and so on. Many resin is my familiar compound. So it is very easy to get a very stable strand from the nozzle in front of the twin screw machine. And the result is next block. This is pelletized plastic compound, and it will be put in the bag and shipped out. And we can do the total preparation of recycling to ship out the product. It's mean perfectly circular system in hand. Okay, next please. Newly developed is non-woven fabric felt, and the width is 1 meter, and this is already get into the production. And normally it requires some additional fiber support to make a dry felt. But in our case, we can control the sizing effect very well. So we can make 100% carbon fiber, recycled carbon fiber felt for mass production. So right now, non-woven fabric is just developed and introduced into the material to several companies co-working together with us to make resin impregnation or RTM to aim the next target node, aircraft interior or automobile structure. All these products can be get priority of SDGs and also LCA evaluation. Okay, next please. I'd like to show the comparison of new carbon fiber and Cobatron together. So original carbon fiber, virgin carbon fiber LCA value is 22.4 tons CO2 per ton. It's very high level. For example, aluminum is nearly 4 tons and steel is 2.3 tons. According to our examination or according to our mass production scale production, our LCA value is 2.5 tons CO2 per ton, very similar to steel. So steel making group cannot talk the negative campaign of that value. So-called the original carbon fiber is 22.4, but after recycling, LCA value is only 2.5 tons CO2 per ton. This is our success. Okay, next please. So I'd like to summarize our new development. We developed a new recycle method in hand and already get into the mass production. And this recycled carbon fiber process with resin, the product meet to SDGs policy, means make a circular system. And recycled carbon fiber RCF shows low LCA value, same as steel LCA level. So my background is steel making company engineer. So feel that recycled materials should be same as original materials, virgin material. So we can establish the SDGs materials in the area of RCF. Okay, thank you very much. Thank you for your attention.